currents, and the base current, if you remember the equation for the base current, the total base current is equal to the total collector current divided by beta. Let's call this one equation number 1. And the total collector current is equal to the DC part of it and AC part of it. DC current plus the AC current. And from this one we can say that therefore the total collector current is equal to IC, that's the DC part of it. And also, if you watch my last video, instead of this AC current, we derived this equation. We derived IC over VT small VB. Okay, this is DC. And let's call this one equation number 2. And if I substitute 2 into 1, use equation number 2 in 1. 2 we have this, and 1 we have this. IC is the total current, and we have the expression for it right here. So if I substitute over here, then this one becomes this whole term divided by beta. So if you divide the whole term by beta, then IB is equivalent to IC over beta plus again IC over beta times VBE over VT. Okay, let's call this one equation number 3. And we know that the total base current should be equal to the AC and DC part of it. The AC part is capital I, capital B, and the DC part, DC part is capital I, capital B, and the AC part is small I, small b. Let's go to equation number 4. Now we are going to compare equation 3 and 4. If you look at 3, we have capital IB, the total current is equal to IC over beta plus capital IC over beta, VB over VT. For this one, we have the total current, base current. Here also total base current, that is equal to IB plus IB, small IB, AC plus DC. And this IB is this small AC part of it is nothing but IC over beta times VBE over VT. Okay, we derived in the last video. I did it in the last video. Okay, and from this one here, you can also see here we have DC part, DC, and this one is AC. And here also you see the AC. We are writing the equation IB. This is the AC current, AC base current, and that's the expression come from this capital IC over beta VB over VT. Okay, and this term IC over VT is equal to transconductance. So you can also express this one as IB is equal to GM over beta times VB as well. Put it in a box, and then if you rearrange this equation, IB over VBE is equal to gm over beta, and resistance, if you look at Ohm's law, V is equal to I times R, therefore R is equal to V over I. Here we have the opposite of it, so if we flip this one, that's going to be the resistance. So we can say R phi is equal to VB over IB, and that is equivalent to beta over GM. Okay, so from this one we can say therefore R phi is equal to beta over GM. And R phi can also be written as beta over, instead of GM we can write IC over VT. So this one also can be IC over VT right here, and this VT can be flipped and written on the top, so this is going to be beta VT over IC. And if you look at the relationship between IC and IB, IC is nothing but beta times IB. Therefore IB is equivalent to IC divided by beta, and here we have the opposite of it. We have beta divided by IC, but IC divided by beta is equal to IB. Then we can write IB on the bottom, so this is here for this one. Let's separate this. Okay, I'm continuing here. So this is VT divided by IB. Okay, we can say therefore R phi is equal to VT divided by IB as well. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.